Click the bell icon to get latest videos from Ekeeda.
Hello friends, in previous lecture we discussed about graph. Basically, graph is a group of vertices and edges which are used to connect these vertices. Now we will look at how to understand the various terminologies which are very important while dealing with the graph. Let us begin with the topic. I have taken the example of directed graph. Let us begin with the terminology number 1. Path. A path can be defined as the sequence of nodes. Which are these nodes? In this case, A, B, C, D, E. These are the nodes that are followed in order to reach some terminal node. In these cases, we are going to reach some terminal node. Let us look at one example. We have initial node named as U. In this case, let us take the example of D. This is your initial node and terminal node. Terminal node is the node in which we want to go for. That is our destination node. Let us take it as C. So our terminal node is C and initial node is D. We want to start our journey from D and reach at C. Let us look at what are the possible path. Path number 1. D to A to B, B to C. This is your path number 1. This is D to A to B, B to C. We have started with the initial node and reached the terminal node. Let us look at another path. We have from B to D. Since it's a directed graph, we can travel from B to D, but we cannot travel from D to B. In similar pattern, we can travel from E to D, but we cannot travel from D to E since it's a directed graph. So the only path which is available from D to C is D, A, B and C. This is called as path, in which we have this set of edges connected to reach from an initial node to the terminal node. Let us look at the closed path. A path will be called as closed path if the initial node and the terminal node is same. That is, we are going to try the value to get the initial node as same as the terminal node. Let's take again the example of the variable that is your node named as D. Okay, so our initial node in this case is going to be D and our terminal node V is also going to be D. As you can see, our initial node and terminal node both are same. We want to start with D and reach again back to D. Let us look at what are the paths possible. From D I can go to A. From A I can go to B. And from B I can go to C. Then I can go to E and again I can come back to D. So this is your path number 1. That is from D to A to B, B to C, C to E and from E I can again reach back to D. This is one of the closed path since initial node and the terminal node both are same. There is again one more path. Let us look at one more path. D to A to B and from B I won't move to C. I am again coming back from B to D. So our path becomes D to A to B and from B I come back to again D. This is also called as closed path. So we have two closed paths. In case of closed path, our initial node and the terminal node both are same. Hence the name closed path. Let us look at the another set of terminologies. Simple path. If all the nodes of the graph are distinct, what do you mean by distinct? Is this specific one, not repetitive. If all the nodes of the graph are distinct with the exception condition, that is V0 equal to Vn, that is initial node equal to destination node or I can say terminal node. In that case, that particular path is called as simple closed path. Cycle. A cycle can be defined as the path which has no repeated edges. It is very important to understand what do you mean by repeated edges. Let us take the example. If I travel from B to D, this is taken as once only. Once again, I cannot travel from B to D. So there are no repeated edges. Also, there are no repeated vertices. That is very important. No repetition of edges and no repetition of vertices. That particular path is called as cycle. Exception is there. That is the first and last vertices. We can take exception of this, but other than this, we cannot repeat the edge, nor do we can repeat the vertices. That particular path is called as cycle. Now we look at the connected graph. A connected graph is the one in which some path exists between every two vertices u and v. So it is very important to understand that there is some connection between the vertices. There is no node which cannot be connected to the graph. There is at least one edge connecting the two nodes. Hence the name connected graph. Complete graph. A complete graph is the one in which every node is connected with all other nodes. It is very important. Every node, or we can say every vertex, is connected to the another vertices. A complete graph contains n into n minus 1 edges, where n is the number of nodes in the graph. Let's take the example. We have n equal to 3. Okay, so complete graph contains how many edges? N into n minus 1 divided by 2. So we have 3 into 3 minus 1 divided by 2. This comes out to 3 into 2 divided by 2. So 6 divided by 2, which comes out to be 3. That is, we can contain only 3 edges in this graph with the nodes as 3. This kind of graph is called as complete graph. Let us look at the another terminology called as weighted graph. In a weighted graph, each edge is assigned with some data such as length or weight. It is very important. Every edge has some weight or length. This is basically to have the cost of traveling from one vertex to the another vertices, or I can say from one node to the another node. Let's take the example. I have A to B edge and it is written 3. It means the distance or the weight or the cost of traveling from A to B is going to be 3. This is how you indicate the weighted graph. In case of weighted graph, you must have the value assigned to edges. This defines the cost or length or weight for traveling from one node to the another node. Digraph. A digraph is a directed graph. So it is very important to have the directed graph. You must remember, in case of directed graph, we always have the direction for traveling from one vertex to the another vertex. So in case of digraph, it is a directed graph in which each edge of the graph is associated with some direction, and the traversing, that is how to travel from one vertex to the another, can be done only in a specific direction. Let us take the example. I travel from A to B. So I need to have the direction from A to B. I cannot travel back from B to A since there is no edge directed at the A. It is very important. This kind of a graph is called as digraph. Loop. An edge associated with the similar endpoints can be called as loop. So you must understand, in case of loop, what happens? Your initial node and your terminal node, both are going to be same and you have the one path only. That particular path becomes your loop. Adjacent node. If two nodes U and V are connected via an edge E, then the nodes U and V are called as neighbors or adjacent nodes. Let's take the example of the graph. We have A, B and C. So these are connected. So this act as A, B and C act as adjacent node since they are connected via an edge named as E. Let us look at the last important terminology of the graph. That is the degree of the node, or I can say degree of the vertex. A degree of a node is the number of edges that are connected with that node. A node with degree 0 is called as isolated node. That is, if there are no edges connected to that particular node, that is called as 0. So degree of node basically defines the number of edges that can be connected to that particular node. Thanks for watching this video. Please subscribe to Ekeeda channel.